3.3, law of sines. So we use the sine law to solve a triangle when we know any side and its corresponding angle. So mathematicians back in the day realized that the ratio in any triangle of a side length to the sine of its opposite angle is equal. So A over sine A is equal to side length B divided by the sine of B, which is also equal to side length C over the sine of angle C. So this was a neat relationship they found and that we can use to solve triangles. So here we have a triangle and we want to solve for x. And we're going to set up a ratio. We know that the ratio of 41 over the sine of 35 is equal to x over the sine of 65. Okay, now all we have to do is cross multiply and we can solve this. So we can say x, oops, sorry guys, my smartboard won't calibrate the way I want it to today. X sine 35 is equal to 41 sine 65. Solving for x, we get x equals 41 sine 65 over sine 35. We want to do this all in our calculator, and we can get x to be 64.78. And again, calculator should be in degrees because we've entered these in degrees. If they were given in radians, you could do this in radians. Okay, something we have to be careful with in the sine law, we're going to see right now. So here we can set up that same ratio again. The ratio of 7.6 to the sine, oops. Sorry, my smartboard's being dumb. It's just like being in class, guys. The ratio of 7.6 to the sine of 27 is equal to sine length 12.3 to the sine of p. Solving this, cross multiplying, we get 7.6 times sine p is equal to 12.3 sine 2.7. Dividing both sides by 7.6 and taking the inverse sign will give us our answer. And then in this brackets, we get 12.3 sine 2.7 divided by 7.6. Okay, when you put this in your calculator, what you're going to get for P is you're going to get 47.29 degrees. Okay, however, you must look at this triangle. So either somebody drew this incorrectly, or you can see that this angle is obviously bigger than 47.29. So the thing about sine, looking at our coordinate system, sine is positive in both the first and the second coordinate. And that's where all angles and triangles are, because all angles and triangles are between 0 and 180 degrees. So we have to be careful because the sine of 47.29 is the same as the sine of 132.71. Or in other words, the sine of its supplementary angle. So whenever you use the sine law, you have to go back, you have to look at your triangle, and you have to say, okay, is that the right angle, or do I have to find its supplement, 180 minus the angle? So just be aware of that. If you get a wrong answer, you're checking the answer book, that's the first thing you should check. Well, is that the supplement of this angle? Okay. Next up, we have a boat being tracked from two stations, Q and R. There's a mistake on my page here. That should be Q. They're 5,800 meters apart on a north-south line. At Q, the boat is observed in the direction of south 55 degrees west, while at R, it is observed in the direction of south 44 degrees west. How far is the boat from Q? Now, what this problem didn't tell us, it didn't tell us that Q is north of R or that R is north of Q. So we have to look at each of these scenarios and see which case it is. Well, in this case, if Q is north of R, we said that from Q, the boat was south 55 degrees west. So that means that this is 55 degrees. And from R, it's south 44 degrees. So this is 44 degrees. Now, if you took these two lines and one was going at 55 degrees out, the other is going at 44 degrees out, these lines are going to continue outwards from one another. In other words, they're going to be like that. That's a little exaggerated. And they're never, ever going to meet. Okay? So this case, Q north of R, they never meet. There's no such scenario where that works out. However, if we have R north of Q, these two do meet. So we said that this was 44 degrees. And we said that this is 55 degrees. Sorry, my smartboard will not calibrate. This is 55 degrees. Okay? So what we have to look at now is how those angles and these sides work out. This we said was 5,800 meters, kilometers, meters. There we go. Okay, so if this is 55 degrees, there's 35 degrees left right here. And so the whole angle, this is a 90-degree angle, the whole angle right in there is going to be 35 plus 90, which is 125. So let's write that in there. This is 125 degrees. Okay, if we know the two angles of the triangle, we can find this last angle because the angles in a triangle add up to 180, and this is 11 degrees. Okay, so now we can use the sine law. So we can say that x is to 11. No, x is to sine of 44, because this is what we really want to find. The question asks us how far is a boat from Q. We want to find this length here, this x. So sine length x is to the angle opposite, which is sine of 44, is equal to, well, the other side length we know is 5,800 meters, and the angle opposite of that is 11, is equal to sine of 11. We're going to solve this out. We're going to cross multiply, and you should get x is equal to 21,115.45 kilometers. Okay, so you should be once you print these out or as you're watching, you should be using your calculator and making sure you can get these, that you can cross multiply and do all your work on your calculator.